Hello everyone, welcome back to the Lingua Loom. Today we're going to discuss another topic of the Music of Speed series. We haven't touched this series for quite a long time, so I thought that we should discuss this. So the topic is Optimality Theory, constraint-based theory of grammar that changed how linguists think about why languages sound the way they do. Not by listing rules, but by ranking competing pressures against each other. So it is one of the most amazing theories and quite famous theory about from the field of linguistics. So before starting the topic, please do like, subscribe and share and do comment as it means quite a lot for the channel. So origin, who introduced it? Optimality theory was introduced by Alan Prince and Paul Smolensky in their 1993 manuscript, which is Optimality Theory, Constraint Interaction in Generative Grammar, circulated through Rutgers Optimality Archive and formally published by Blackwell in 2004. So first, who is Alan Prince, a linguist at Rutgers University working on phonology and metrical stress. Prince had already been developing constraint-based alternatives to rule ordering before OT crystallized. Then Paul Smolensky, a cognitive scientist and based at the connectationist, based at the time at the University of Colorado Boulder. His background is neutral network style parallel constraint satisfaction shaped OT's core mechanism. So basically, he's not a linguist. Then comes John McCarthy, joined Prince soon after in developing correspondence theory, the submodule of OT, which is optimality theory. This is the short form that is mostly used, OT, that formalized faithfulness relation between input and output forms, becoming the theory second major architect. So why this matters? OT did not emerge in a vacuum. It grew out of felt limitation in 1980s rule-based phonology. Order rewrite rules could describe patterns but rarely explain why language preferred one repair over another when a structure disallowed. So this is what caused the emergence of this theory. Then let's look at the core idea. The core idea, instead of applying a fixed sequence of rules, OT proposes that every language shares the same universal set of viable constraints. What makes languages differ is not which constraint they have, but how they rank those constraints in order of priority. First we have markedness constraint, ban structurally different or dispreferred configurations. Example, complex coda, it disprefers clusters of consonant at the end of syllable. So this is one of the constraints in OT. Constraint are used. Then comes faithfulness constraint. Demand that the output resembles the input as closely as possible. Example, max penalizes deleting a sound, dep, which is depletion, penalizes inserting one. So the core constraints are markedness and faithfulness. These are the two constraints of OT. Then under OT comes that under markedness comes different constraint, and under faithfulness comes many different constraints. So this focuses on changing its output bit. This states that output should resemble input as closely as possible. So grammar in OT terms is simply a ranking of those universal constraints from most to least important for the given language. Changing the ranking and you get different language sound pattern without changing the constraint themselves. So let's at least look at the core idea again. So what is the core idea? Core idea is that every language in every sound or every pattern, they violate some rules. So we pick out the best possible outcome which violates the minimum or least constraint. Every candidates are the words used for the terms in this. So every constraint, they violate some rule. So the one that violates the least rule is picked up as a best possible solution. Then let's look at why this belongs to phonology, not phonetics. It belongs to the field of phonology, which is syllables, segments, feature, morals, not our raw acoustic or articulatory measurements. That distinction is the actual reason OT is classified as phonology. As phonetic source, what are the measurable physical properties of sound? Its form and frequencies, voice onset time, tongue position, airflow. Phonetics is the continuous and instrumentally measurable, whereas phonology asks how does a language mentally organize sounds into categories and patterns, which sequences are permitted, which get repaired, and why. Phonetics is categorical and computational. So that's why this shows that why OT belongs to phonology, not phonetics. So OT constraint candidates in a tabulu, which is table, you can say it's simple but like limp, as the word there is limp having limp, versus these are the candidates that we're going to decide for doing OT analysis. A limp, what's the limp? A limp or phonological forms built from discrete segments and syllable structure. Gen does not generate continuous acoustic variants, and eval, which is evaluation, we'll discuss it later, does not measure them in physical genres. The theory's entire object of explanation is sound patterning, which is the definition of phonology, not a physical execution of language, which is phonetics. So where the two connect, some Marquez constraints are said to be phonetically grounded, meaning their ranking tendencies are motivated by articulatory or perceptual difficulty. For example, consonant clusters are cross-linguistically dispreferred partially because they are harder to perceive and produce. This is a point of contact between two subfields, not evidence that OT itself is a phonetic analysis. So constraint inventory working list, let's look at that. So these are Cone is not an open-ended toolbox where analysts can invent your own. There's a huge list. You can check out the work of the above mentioned contributors. Then these are some, just some. There are a lot of constraints. So these are most widely used. These are markedness constraint which bans this preferred structure. First constraint is onset. What does it say? Syllable without an onset consonant. The typical effect is drives, epenthesis, or resimplification to give syllables an onset. So it is how you use them. Then no coda, any syllable final consonant. This is what it bans. Then favors open CV, complex onset, complex coda, consonant cluster at syllable edges. It bans this. Then voiced obstruent coda, voiced obstruent in coda position. It bans this. Then agree voice at adjacent obstruent disagreeing in voice, which is passive voice and active voice. Then faithfulness constraint, preserve the input, which is max constraint. These are the short form, they're the maximum or maximum input, or these kind of full names are there. You can check out the full work and read them in detail, but they are written in short forms. So every input segment must have an output correspondent. The depth, which is appellation, every output segment must have an input correspondent. Identify feature, it is about feature, input and output correspondent must match in feature. Then linearity, a linear order of segments. The point of the list is different language produce different sound patterns, not by inventing different constraints, but by ranking this shared inventory. So you don't have to use all of them, as their list is quite big. You can't use all of them at once. You just pick up some according to your study and use them in your work. But it's not like that random. You have to specify and work properly that which constraint is used and good for your study. So let's move forward. The machinery, how evaluation works. So every OTA analysis runs through three components, always in this order. First, gen, as we discussed earlier. So it is generator. This is the full form of it. Takes an underlying input and generates every conceivable output candidate, including wildly unlikely ones. Then cone, which is constraint set, the universal ranked set of markedness and faithfulness constraint every candidate is measured against. Then eval, which is evaluator, compares all candidates against the rank constraint and select the one with the least serious violations as the winner. So the key principle is that constraints are violable. That is what is discussed earlier, that they are breakable. It is not like that they are fixed and cannot be breakable. The one who breaks the less constraint, that is the constraint that wins. Candidate, that's the candidate that wins. Then worked example, last three. Look at the three examples. So this is called a table. Let's just say table. So there are candidates or rows. These are the candidates. Then comes ranked constraint as columns. So these are the columns, like this max and depth, and they are columns. So violation is marked by this asterisk symbol, and the fatal violation is marked with asterisk and exclamation mark that eliminates a candidate and that is out of the competition. So one example rarely shows the full range. Let's look at the first one, example number 1, which is limp. English keeps the cluster rather than repairing it. Max and depth outcome outranks. So we look at the outranks complex coda. So this is the one that wins, and here hand symbol is used to show that which one wins. This as this violates the least constraint. This is as it violates the serious one. So that's why they both are out of the competition. So limp wins. Limp loses because it fatally violates the high-ranked max deletion. Limp, which is the second one, loses because it again violates like the same one. The winner survives by violating only the lowest ranked constraint, which is complex coda. So you have to give explanation to that why some constraint win and some don't. Then comes Japanese repair the same cluster by parenthesis. Loanword adaptation input, that is Sotoraiko type cluster from English, which is strike. Sotoraiku. Japanese instead repair consonant cluster by inserting vowels because in Japanese complex onset complex coda outrank depth. The opposite ranking from English, as here the first one is complex output input, and above here it is complex coda in the lowest column and max and I. This is not just random. It shows that this one wins, then this is second place, and this is the lowest place. Then again with the third example, this is input with the voiced obstruent. You can just pause it and read it. So here it is what I said earlier. The winning candidate is never the one with zero violations. It is the one whose violations are very minimum in number as compared to the other ones. The high-ranked violation is always fatal, no matter how low-ranked constraint a competitor violates instead. So how constraints are selected? It is not arbitrary. A common misconception is that analysts can invent or pick constraint freely to fit whatever pattern is being described. Well, it is not. Cone is claimed to be universal and fixed. Prince and Smolensky's foundational claim is that all languages share the same constraint set. Only the rank differs. An analysis is expected to draw on its shared inventory rather than mint or new constraints solely to force one's language result. Then constraint must be independently motivated. A proposed constraint needs support beyond the single pattern. It is invented for typical phonetic grounding or evidence that it does real work in other unrelated patterns or languages. Then comes factorial topology is the real test. If a consonant set is correct, then every possible ranking of those constraints should correspond to the attested human language pattern, and no ranking should predict a pattern that no language ever shows. Analysts have proposed constraint against this, and constraint that generates impossible languages under some ranking is a warning sign. Then rankings are learned from data. So Tesar's and Smolensky's constraint demotion algorithm, written in 1998, formalizes how a specific language ranking can be derived from comparing winning form against losing competitors in actual data, progressively demoting constraint violated by winners below constraint violated by losers, rather than analysts simply declaring a ranking by intuition. So, in short, the constraints available for any analysis come from shared, independent, motivated inventory, and the ranking for the language is argued for using minimum pair style evidence, not chosen freely to make single example that comes out. So, how OT has evolved first started in 1993, given by Princess Smolensky, as their manuscripts circulated through Rutgers. So introduced Jan Cohn Ewell and constraint ranking. Then 1994 McCarthy and Prince formalized correspondence theory, giving faithfulness constraint a rigorous input-output mapping framework. Then late 1990s stochastic OT, which is given Boersma, introduces probabilistic constraint ranking to model gradient acceptability and free variation rather than strict categorical ranking. Then comes 2000s, which is harmonic grammar, re-emerges as the weighted constraint alternative to strict domination, addressing cases OT ranking mechanisms struggle to capture. Then 2004, the original 1993 script is formally published as a book by Blackwell, cementing OT's place in mainstream generative linguistic curricula. From 2000 to present, as it moves forwards, OT extends well beyond phonetics into morphology, syntax, and sociolinguistic variation, while continuing to face active competition from rule-based and weighted constraints alternative. So this is how it moved. Then beyond phonology, although OT was born in phonology, its constraint ranking logic proved portable to other grammatical domains like syntax. Jane Grimshaw and others applied OT to word order and structural economy, treating syntactic well-formedness as constraint competition rather than derivation. Morphology OT has been used to explain competition between affixes, blocking effects, and paradigm gaps as output of ranked morphological constraint. Then sociolinguistic variation. Stochastic OT in particular has been applied to model free variation and gradient acceptability judgments across speaker population. Criticism and ongoing debate. OT is influential but not universally accepted. Several critics worth knowing are opacity problem. Because OT evaluates input to output mapping in one parallel step, it struggled to naturally capture opaque rule interactions that classical derivational phonology handles by ordering rules in sequence. Then comes richness of the base. Critics have questioned whether OT's claim that all cross-linguistic variation reduced to constraint ranking is empirically sustainable more than languages are analyzed in depth. Then comes computational complexity. Comparing infinite candidates set generated by Gen raises computational tactability question, which has motivated formal and algorithmic work of how ABEL can be computed effectively. So these debates are active within theoretical phonology, not settled history, or to remain one live framework among several, rather than uncontested consensus. So where it stands today. OT remains one of the dominant frameworks taught in graduate phonology alongside rule-based derivational approaches and weighted constraint models like harmonic grammar. It is a standard part of linguistics curricula worldwide and continues to generate active research, particularly reliability, computational modeling, and cross-linguistic topology. So bottom line is that OT is neither a settled final answer nor a fading relic. It is active, contested, and still widely taught framework over 3 decades after its introduction. So this is it for today. I hope you understand it. So in simple words, OT is a theory that says that we can have a best possible outcome by setting up constraints, and the thing that is being constrained is candidate. So you do analysis based on certain constraints, and the best possible outcome is the something that is accepted widely. So that's it for today. I hope you understand it. Thanks for watching. Please do like, subscribe, and share, and do comment. And have a good day.